This is Math 55, starting the first section. So we're going to look a little bit at solving equations. This is mostly review, so it's hopefully stuff that you've got a pretty good background for. We're going to look at all kinds of different types of equations that we're going to need to learn how to solve. Okay, so to begin with, let's go down and look at a few things. This is kind of a general rule of thumb that I like to teach students to go through. So basically, if you're solving an equation, you want to collect any like terms that you have on a side of an equation. If you have variables on both sides, generally you can eliminate the smaller of the two. You don't have to, though. That's just kind of a way I like to do that. I'll also look at how you can rearrange things. You isolate the variable, and then don't forget to check the solution. Checking is a great way to build good arithmetic skills, and it's also a really good way to tell if you're right, obviously. Okay, so let's go ahead and take a look at starting with this one right here. Now keep in mind on equations, when you start off fairly simple, a lot of times you can tell if you're right. So for instance, if we tried the number 2, for instance, if we just plugged it in, this problem says 9 times 2 minus 5. Well, that's 18 minus 5, which is equal to 13, so that's not equal to 22, so that can't be the right answer. But, we could try again and see. I just want to show you kind of that sometimes you can trial and error this. Let's try 3. So 9 times 3 is 27. 27 minus 5 is 22. So that would be the answer to the problem. Now, that's not the ideal way to solve equations, but sometimes when equations are fairly simple, you can go through and do it that way then. All right, so I'm going to take you through the general strategies that we generally do for this when we solve equations. So to begin with, what I'm going to be looking at here is the general process. Now, what I'm going to do on this is we have 9 times n minus 5 is equal to 22. Well, the idea is you want to get this n by itself. So what you want to do is you want the 5 to go away and the 9 to go away. And you got to do it in this order, and you're undoing operations. Generally, the opposite of subtraction is adding. The opposite of multiplying by 9 is dividing by 9. And you want to do this in a certain order. You generally want to get rid of the number that's in front of the variable at the end of the process then. So what I'm going to do is I'm going to add 5 to both sides of this equation. And we can do that. We're keeping everything in balance. We're not changing anything. If we add 5 to both sides, we're keeping everything the same then. It's kind of like a balance scale. Right? So now if we write our next step, what we have is that goes to 0. So you really have 9n plus 0 is equal to 22 plus 5 is 27. And of course, anything added to 0 is itself, so now you have 9n is equal to 27. Okay? Now what you can do is you can divide both sides by 9. So what you would end up having then, see, is this. Okay? 9 divided by 9 is 1n. 27 divided by 9 is 3, so you just get n is equal to 3. Now there's several steps that I wrote on here that you can bypass. As I'm teaching and reviewing this, though, I want to show you specifically what's happening. You don't necessarily have to put that plus 0 step there. You don't necessarily have to put that 1n step there, but I want to make sure that you understand all the details of that, so when you're doing these problems, you can eliminate that if you want to. Now, if you check, your answer is 3, so you're just replacing n with 3 like we showed before. 9 times 3 is 27. 27 minus 5 is equal to 22. So you end up with 22 is equal to 22. So it's the right answer to the problem. Okay, so that's one way to do that, to go about doing that problem. All right, so let's move on and look at the next problem then. And what you get in on this one is you now have variables on both sides. And I'm going to show you a couple of ways to do this. As I go through these problems, I'm going to look at probably 2 different ways to look at this. So I do want to go back to this number 1. I'm going to erase this, and I'm going to show you an alternative strategy. It doesn't really matter to me which way you do this. So what I'm going to do here is you can also learn to just sort of rearrange and move things. So for instance, you want to keep the n on the left side so it's isolated. So you can move the 5. So since you're adding 5 to both sides, you can do this if you want to. You can write your step as 9n equals 22 plus 5. So when you move that 5 to the other side, you're just adding it. You're doing the opposite process there. Opposite of subtracting is adding. So you have 9n equals 27. Then you can divide both sides by 9. Of course, that's 1n, so that's just n equals 3. You can write the step that way if you want to. Okay. All right, let me show you this next one. And I'm going to do this one in 2 different ways. The first thing is, notice that I have a variable on both sides. I have a 10y there and I have a 2y there. It doesn't really matter which side you get the variable on. So what we can do with this is you can get rid of one of those. And I usually will teach students to get rid of the smaller one. So 2 is smaller than 10, so I'm going to subtract 2y from both sides. And you can write the step like that if you want to. Okay, so that's going to be, when you do this, that goes to 0y. So that's going to, this side's just going to be now 0 minus 5 equals negative 10. And then 10 minus 2 is going to be plus 8y. So we end up having negative 5 equals negative 10 plus 8y. So you can do it like that. Again, you can bypass this second step right there if you want to. You don't have to put the 0 minus 5 because you're kind of doing that in your head. Okay, now the next thing I want to look at is I want the y to stay where it is. So that means that what I need to get rid of is this negative 10. So the way to make negative 10 go to 0 is to add 10 to it. So I'm going to add 10 to both sides like this. And then what I'll have is, when I do this, negative 5 plus 10 is 5. This goes to 0 plus 8y. Okay, so I've got 5 is equal to 8y. Now, if I want to get y by itself, I undo the operation of multiplication. 8 is multiplied, so I divide both sides by 8. All right, so what I end up having now is I've got, this is really 1y. This is 5/8, so I just leave the 5/8 alone. 1y is y, so I get an answer this time of a fraction of 5/8 like that. So that would be one way to show your steps on that problem is like that. I'm going to show you different ways to write your steps, so that's one way. Okay, if you want to do it that way, you can. The other way, and I'm going to go through and check this in just a minute, is to rearrange. I like to kind of get people used to, at this level of a class, kind of rearranging too. All right, so I'm going to erase this and I'm going to go back through and show you how to do it this way. Okay, so what I'm going to do on this is I'm going to get all of my y's. And it doesn't matter what side you put your y's on. Let's just put them on the left side this time. Okay, so what I'm going to do is I'm going to make the decision that all the y's go on the left side. So this thing right here, I'm going to keep it where it is. Just leave it alone. Okay, then this thing, I need to move it. Now, since that's adding, the way you get rid of adding is by subtracting. So when I move that, that's going to be minus 10y. Okay, now I'm going to bring down the equal sign now, and I'm going to leave this where it is. So I'm going to do that. And then this number 5, I need to move it to the other side. Okay, so since that's subtracting 5, I'm really adding 5 to both sides. So I do a plus 5, like that. Okay, now see, the cool thing about learning to do it this way is, see, all your y's are together, all your numbers are together, so you don't have to write as many steps. So you're going to have negative 8y here equals negative 5 when you add those two numbers together. And now what you can do is divide both sides by negative 8. Okay, so what I'm going to end up having here is that goes to 1. And the reason I divided by negative 8 because I want that to be a positive 1y. Right, now if I divide two negatives, I get a positive, so that's 5/8. So the answer is y equals 5/8. So that's kind of a cool way to write your steps is like that. You got a lot of arithmetic going on the problem, so you got to be sure that you know how to handle your arithmetic on these problems too without a calculator. You don't need to get reliant on your calculator, okay? All right, let's check this. So let me show you how this works. So what I'm going to do is everywhere I see a y, I'm going to replace it with 5/8, and I got to deal with the fraction arithmetic. So I'm going to come down here and I'm going to do 2 times the answer, which is 5/8, Then I'm going to do minus 5. And I'm going to see if that's equal to the other side of the equation. Okay, like this. So I got minus 5. Then I'm going to see if this is equal to the other side, which is negative 10 plus 10 times, and then replace that 5/8, the y with 5/8. So I'm going to plug that in like this. All right, so I got 2 arithmetic problems really to work out. Now we're going to see if they turn out to be the same. All right, so you put this over 1. You can multiply this fraction. Now you can go straight across and get 10/8 if you want to. So let's just go ahead and do that. Or you can reduce if you want to. So we're going to go ahead and just do 10/8 minus 5. And let's go ahead and work that out. Now you can reduce this fraction by 2. So 10 divided by 2 is 5. 8 divided by 2 is 4. So you've got that. Now I'm going to put the 5 over 1 and I'm going to get a common denominator. So the common denominator between 4 and 1 is 4. And remember, if I'm dealing with a fraction, I got to do the same thing on top and bottom. If I don't multiply both the top and bottom of the fraction by 4, I'm changing the problem. So what I get here is 5/4 minus 20 over 4. Notice that 20 over 4 is 5. So that's going to be 5 minus 20 is negative 15 over 4. Now we're going to go over here and we're going to do the same thing. Okay. So when I do this, I'm going to bring down the negative 10. I'm going to put that over 1. I'm going to multiply straight across. So that's going to be plus 50 over 8. You can reduce that fraction by, actually by 2. So we got negative 10 here. 50 divided by 2 is 25. 8 divided by 2 is going to be 4. So now I can get a common denominator. Okay, so I'm going to do the same thing I did in the last. I'm going to multiply that by 4 over 4. That's going to give negative 40 over 4 plus 25 over 4. And if you add that together, you get negative 15 over 4. Okay, so that checks and verifies that it's the right answer, see. Checking, a lot of times students are very lazy about doing that. And it's a really bad idea to do that, because if you check your answer, one of the benefits of doing that is you're strengthening your arithmetic skills. A student in this level class should have no trouble checking an answer. I'm serious. And you don't want to use decimals and stuff like that. You want to do it by hand. All right. Now, I do want to show you that you can do this also. It's not wrong to do this. I'm going to pull up my graphing calculator here, and I'm going to show you that you can do this. Now, if you needed to do a quick check, just using technology, you can do this. So I could go back to my problem, which is 2 times, then I could do like a parenthesis, and then I'm going to put in 5 divided by 8, like that. Okay, and then subtract 5. Okay, now I'm going to get decimals, so I get that. Now I could go to the right side. I've got negative 10 plus, I'm going to take 10 times y. And y again is 5/8, so I'm going to use a parenthesis, and I'm going to put 5 divided by 8. Okay, so if you look at that, it's the same. So see, you can use technology to check your answers also, all right, which is kind of cool. Okay, so that's how you could do that problem. Those are a couple of different ways of doing this. There's many ways to go about doing this stuff. So that would just be one of the ways. Now I'm going to move on to the next page. And, oh, come on, work. Okay, so I'm going to move on and do next problem here. And this one of the things I said is collect like terms if you can. So one thing on this that I want to review is you can think of this as a 1 being there and a 1 being there if it helps you. And then we have the distributive property that I hope that you've learned about. So if we did just 1 times y, we get y. If we do 1 times 4, we get 4. Same thing here. If we do negative 1 times y, you get negative y. If you do a negative 1 times a positive 2, you get a negative 2. So that's the distributive property. Now, you don't have to put those ones in front of there. That's just showing you what this means. Okay, now, collect like terms. The like terms are this and this, and this and this. Put them together. So when you do that, y minus y is 0. Negative 4 minus 2 is negative 6. Don't get your calculator out on that. That's silly to get your calculator out. All this problem means is you're 4 below 0, and then you're going 2 more below 0, so you're 6 below 0. Temperature's 4 degrees below 0 outside. Temperature drops 2. You're 6 below 0. Come on, think about that. All right, so now what we get is negative 6 equals 5y. Now what we're going to do is we're going to divide both sides by 5. That'll technically give you 1y is equal to negative 6/5. So you get the answer is y equals negative 6/5. Okay, so that's one way of doing that problem. Okay, that's the simplest way, is collect your like terms, then you get your answer. Okay, all right, now what I'm going to do from here is let's go ahead and check our answer. Would like you to be able to do that like I've been saying. So we go to the problem, which is something minus 4. So our answer is negative 6/5 minus 4. Subtract something, which goes there as the negative 6/5, and then plus 2. And then we're going to see if that's equal to 5 times the answer. Okay, so what we're doing is we're just going back and we're replacing y with this, leaving everything the same way. Okay, and don't be intimidated by doing this. This is not that hard. It's stuff that you got to learn how to do if you're going to be decent with math. So I'm going to get common denominators here and just kind of work inside parentheses. So the common denominator between 5 and 1 is 5. So what I'm going to do is I'm going to multiply this fraction right here by 5 over 5. Okay, when I do that, now what I'm going to have is I'm going to have negative 6/5 minus 4 times 5 is 20. 1 times 5 is 5. So we got that. All right, I'm going to do the same thing here. I'm going to put that over 1. Going to get a common denominator, so I'm going to multiply that by 5 over 5. So what I'm going to have left over here is negative 6/5. 2 times 5 is 10. 1 times 5 is 5. And then when we go to this side, I can multiply that straight across. Now, and you can reduce out the 5 and 5 if you want to. That's the simplest way to do that, is 5 divided by 5 is 5, so that just gives negative 6 over 1 when you multiply that straight across, so you get that. Okay, now let's put this together. So when you put this together, you keep the denominator. You're adding 2 negatives, so that's negative 26 over 5. Okay, go here, keep the denominator. Negative 6 plus 10 is positive 4. If you struggle with that, you have $10. You're 6 in the hole. You give the bank $10. Okay, you're 4 out of the hole. That's the easiest way to think of it. Okay, now I'm going to bring this down and see if this is right now. So now what we have is 2 negatives, 2 debts. Negative 26 minus 4 is negative 30 over 5. And that's correct. Okay, because negative 30 divided by 5 is going to be negative 6. So that checks. So that's right. Okay, so what I'm going to do here, what I do on these recordings a lot of times is I pause and then I have you work out problems. So I'm going to have you work out the next problems. Okay, we're going to go work out number 4, 5, 6, and you're going to check them also. All right, so let's go ahead and work on that a little bit. Okay, so I'm going to go ahead and run through these problems now, and you can do your steps in several different ways like I've been showing you. So what you want to do with this, one way to do this problem is you want the y to be, or the r to be by itself. Okay, so if this thing's going to be by itself, that means that the 6 has to go away and the 7 has to go away. The way you make adding go away is you subtract. Okay, so we could subtract 6 from both sides. You can write it that way. Okay, then when you do this, that goes to 0. So you really have 7r plus 0. You don't have to write that step. 69 minus 6 is 63. So this gives 7r equals 63. Okay, now if you want to get rid of 7, 7 is multiplied. The opposite of multiplying is dividing. So you divide both sides by 7. Okay, so you end up getting technically 1r. 63 divided by 7 is 9, so you should have got r equals 9. So that's a real good way to write your steps, is like that. Okay, checking's real easy. You just go back to the original problem and you plug in the 9 right there. Okay, So when I do that, let's go ahead and do that over here. So I'm going to replace that. Okay, and work it out. So 7 times 9 is going to be 63 plus 6, and that's equal to 69. Okay, so it does check out. You get the right answer. Okay, so that's one way to do the problem. You can write it that way. I am going to erase this and show you that you can move things too. So I also want to do that real quick. So if you want to start learning how to do it this way, you're more than welcome to do that. We want the arb to be by itself. So that means we need to move the 6. When we do that, we just have 7r equals 69 minus 6. Okay, because you're subtracting from both sides to get rid of the 6. You have 7r equals 63. Then you can divide both sides by 7. That's 1r. So you can write it like that. You don't have to write all the steps I'm writing. I'm trying to be very cautious on this section to show you precisely mathematically what's happening, because a lot of times students have never made those connections. Okay, next problem. Okay, now what you want to be sure that you see on this one that's real important is you have like terms, and you need to put them together. This is the best strategy on this problem, is to start there. Don't do anything else, just do that. So don't do anything to the left side. Just write that as 7y minus 4 is equal to 10, and then 9 plus 4 is going to be 14y. Like that. Now the next thing you want to notice is you have variables on both sides. You don't want that. So you need to get rid of one of those. It doesn't make any difference which one you get rid of. You can get rid of the 14, you can get rid of the 7. It's your call. What I tend to do on this is show students to get rid of the number that's smaller, but you don't have to. So I'm going to make the 7y go away. So I'm going to subtract 7y from both sides. You can draw a line if you want to, okay? And then what we get on this is that goes to 0 technically. I'm going to write that as 0 minus 4, 10, and then 14 minus 7 is going to be plus 7y, okay? Collect those like terms. That's negative 4. This is equal to 10 plus 7y. Okay, so you can start that way if you want to. Now, when you get to this point, that needs to be by itself. So that means the 10 and the 7 have to go away, so y is by itself. So this 10 is added. It's a positive number added. So we need to subtract it from both sides. So you would get negative 4 minus 10 is negative 14. That would go to 0. So you get this. Then this would be negative 14 equals 7y. Then what you can do is divide both sides by 7. Okay, so when you do that, that gives you 1y is equal to, and then negative 14 divided by 7 is negative 2. So you get y equals negative 2. So that's all the steps. There are some things you can bypass on that. All right, so what I'm going to do is I'm going to plug that in. So if you go back to the original problem, if you want to check this, what you have to do is everywhere you see a y, you got to replace it with negative 2. All right, so I've got everything set up over here. So you're going to do 7 times negative 2 minus 4 on the left side of the equation. Then you're going to do 10 plus 9 times negative 2 plus 5 times negative 2. Okay, work out the details. So this is negative 14 minus 4. And we're going to see if that's the same as 10, and then this is minus 18, and then that's a positive times a negative, so that's minus 10, like that. So this side's two negatives, that's negative 18. 10 minus 10 is nothing, so you end up getting that goes to 0, so those things are the same, so that checks and verifies that it's the right answer. Okay. All right, so I'm going to run through, I'm going to erase this, and I'm going to show you the alternative method. Kind of helps your step writing if you learn to do it this way. So the way I would do this, if I was solving the problem, I'd do it like this. I would start again by collecting those like terms. Just write down the left side as it is. 7y subtract 4 is equal to 10 added to 14y. Now, get your y's on the left, get your numbers on the right, or you can do that opposite, doesn't matter. So what I'm going to do is I'm going to leave this where it is. I'm going to make the decision that all my y's go on the left. So this thing's just going to come down. This thing is going to move. Move it to the other side. So it's got a plus there. So when you move it, you're subtracting 14y. So write it that way. Okay? Bring down your equal sign. Okay, the numbers all are going to go to the right side. So I'm going to just write the 10 down, and then this thing is going to go to the other side. So since that's a subtraction, you're adding to both sides, so you just have plus 4. Okay, collect your like terms. 7 minus 14 is negative 7y. 10 plus 4 is 14. Now you can divide both sides by negative 7, and you'll get the answer. So this is positive 1y. This is negative 2. That's what you want. So y is equal to negative 2. All right, so either of those two ways are good ways to write your steps. Okay, next problem. You have to start with well, you don't have to start with a distributive property, but it's probably a reasonable way to do this. Okay, so I'm going to go ahead and do this. I'm going to do a distributive property like that. So I've got negative 6 times 4x is negative 24x. Negative 6 times negative 1 is plus 6. Bring down the 24 like that. Okay, now what I'm going to do is I don't have any like terms. I don't have any x's on the right side, so I just need that thing to be by itself. So I need to get rid of the 6, so I can subtract 6 from both sides, like that if I want to. And you can draw a bar if you want to. If you like showing your step that way, that's fine. And if you write this down, see, this is going to go to 0, so you have negative 24x. Plus 0, 24 minus 6 is 18. So you have negative 24x equals negative 18. Okay. Then what you can do is you need to get x by itself. So you need to divide by the number in front. So divide by negative 24. And when you do that, that's going to end up giving you positive 1x, which is what you want. So we got 1x, and then the right side you have negative 18 over negative 24. Now two things go on this. When you divide two negatives, we know a negative divided by a negative is a positive. So you get x equals 18 over 24. Then yeah, you do need to reduce that fraction. So both of these numbers divide by 6. So you're going to end up having x is equal to 18 divided by 6 is 3. 24 divided by 6 is 4. So it looks like the correct answer to that problem is 3/4. Okay? So that would be the best way to show your steps on that, is like that. Now I'm going to check the answer. So the answer we have is negative 6 times, in parentheses, you have 4 times the answer minus 1. Close the parentheses, and we're going to see if that's equal to 24. So I'm going to replace the variable with 3/4, work out the details, and see what happens. Okay, so order of operations would say work inside this parenthesis, and notice you can reduce out the 4's. So then what you would have is negative 6, parenthesis, this whole thing becomes 3, minus 1, and we'll see if that's 24. So that's negative 6 times, whoa, what in the world did I just do here? Okay, every now and then the teacher makes mistakes, which is okay. My mistake's real simple right here. You probably saw that if you were watching this. 24 minus 16 is positive 18. All right, so what we end up having is positive 18 over 24. So now we end up with a positive divided by a negative is a negative. So you should have ended up getting negative 3/4 as your answer. So here's what happens. Okay, if I go back, now that should have been an answer of negative 3/4. Then you would have negative 3 there, see. Okay, so now what you get is negative 3 minus 4 is negative 24. And we'll see if that's 24, and it is. So that's 24 equals 24. Checks the answer. And again, that's the reason why you want to check your answers. I could lie to you and say, hey, I meant that, but I didn't mean that. I make mistakes too. That's how I catch my mistakes, as I try to check my answers, okay? All right, so that would be the idea on those kind of problems. I do want to show you one other thing real quick. You can, I want to try to get people in the habit, if you're comfortable, of just learning to move things and rearrange things in these kind of equations. So you could start like this with the distributive property. So that's negative 24x plus 6. Be careful about that now. See, that's a negative 6 times negative 1, so that's positive 6. Now what you can do is leave the x where it is, so you can actually just move the 6 to this side, writing your answer. Your next step is negative 24x equals 24 minus 6. Then this is negative 24x equals 18. Then we can divide both sides by negative 18, or not negative 18, come on. I know better than that. Divide by negative 24. And then when I do that, that gives you 1x, and then you can reduce the fraction. So you have x equals 18 over negative 24. That's a negative answer. And then you can divide, when you reduce the fraction, you can divide both sides by 6 to get 3 over 4, like that. Okay? All right, a couple of things I do want to mention on this. When you have a negative fraction, you can write a negative fraction either like this. That's one way to write the answer. You can also write it as negative 3 over 4. You could even write it as 3 over negative 4, although that's not the preferred way. It is the same. Those are the two preferred ways to write the answer, okay? But don't write it this way. Sometimes I see students write it that way. No. Two negatives divide to make a positive, so that would not be the correct way to write it. Okay, so just in case you need a refresher on that. Okay, now we're going to move on and do some that are a little bit more complex. Going to number 7. The thing that you want to see on this problem is you have a distributive property, so you want to start there. Just look at that little piece of the problem right there. So we're going to start by doing the distributive property, multiplying the 4 times the 2 terms inside the parentheses. So bring down the negative 7x. Don't forget about that. All right. Now what we have, be careful now. You have a 4 positive times negative. That's negative 8x. So just write it that way. Write that as subtract 8x. You have a 4 times negative 6. Again, that's a negative result. Just write it as subtract 24. Bring the equal sign down. Bring the right side down. Just keep rewriting stuff when you do an algebra problem. Step by step. Not in a just in a column like that. Next thing is we have like terms. Those things need to go together. Don't do anything else. Collect like terms together. So that's 2 debts being collected. So that's negative 15x. Subtract 24. This is equal to negative 30 minus 9x. Now what you can do here, if you want to rearrange, you can rearrange. Okay? So what I'm going to do on this is I'm going to make the decision that I want all of my x's on the left side. Okay? So I'm going to take this, and I'm just going to write this down. And I'm going to take this x, and I'm going to move it to the other side. Okay, since that's subtracting 9x, I'm adding 9x to both sides. So I'm going to put a plus 9x there. Then I'm going to bring the equal sign down. Now the numbers are all going to go to the right side, see. So I'm going to just write down the negative 30. Then I'm going to take the minus 24, and I'm going to rearrange and move it to the other side. Since that's minus 24, you're adding 24 to both sides, so you write that as plus 24. Kind of a nice, nifty way to write your step. Okay, now you can collect like terms. So these go together, that's negative 6x. These go together, that's negative 6. Now you can divide both sides by negative 6. That'll divide out to give you 1, so we get 1x equals 1. Those are 2 negatives, that divides out. So you get x equals 1. Okay, that's one of the best ways to write the step is like that. Okay. Now, I'm going to erase that, and I'm going to show you an alternative way to do this problem. If you don't want to do it that way, you can do it this way. You're still going to start with the distributive property, so you're going to start with negative 7x minus 8x minus 24 equals negative 30 minus 9x. So you've got to do that distributive property first. You've got to collect the like terms, so that's negative 15x minus 24 equals negative 30 minus 9x. Okay, now it's up to you. you got variables on both sides. You don't want variables on both sides, so you got to get rid of one of them. It doesn't make any difference which one you get rid of. I'm going to do it this way. I'm going to get rid of this one. Okay, it's your call though. So I'm going to add 15x one time to both sides of the equation. Okay, you can draw a line if you would like to. Okay, when you do that, that goes to 0. So that's just 0 minus 24. This side is negative 30 and then plus 6x like that. You can do it this way if you want to. Right, so moving it over here, 0 minus 24 is negative 24. This is equal to negative 30 plus 6x. Okay, we want to get x by itself. If you want to get x by itself, that means 30 and 6 have to go away. So get rid of a negative number by adding once to both sides. Okay, draw a line if you want to do it this way. Okay, and then that's going to be 6. That goes to 0. So you have 6 equals 6x. Then you can divide both sides by 6, which will isolate the x by itself, giving you 1x equals 1. So you get the answer x equals 1. So if you prefer writing your steps that way, you can do it that way. Okay, next problem. Start with distributive property on the next problem. Okay, we got a distributive property there. We got one there. Okay, so we're going to multiply those two things out. We're going to multiply those two things out like that. So negative 3 times 2p is negative 6p. Negative 3 times 15 is negative 45. So subtract 45. Bring the 30 down. It's still there. Negative 2 times p is negative 2p. Negative 2 times 16 is negative 32. So write that as subtract 32 like that. Okay. And that's how you got to start the problem. Now look for like terms. Those are like terms. Put them together. On the right side, these are like terms. Put them together. Okay, so we got negative 6p. This is two debts collected. If you add those numbers together, you get 75, but it is a negative. Okay, this side, we got this situation. Now, instead of grasping for your calculator, just pretend like you have money. Okay, you have a debt of $32. You give the bank $13. You're still in the hole. If your debt is bigger than your money, you're in the hole. So you're in the hole. So what do? You do 32 minus 13. So you got to regroup and make that a 12. 12 minus 3 is 9. That's 19. So it's minus 19 though. Okay, don't get your calculator out. We live in this world where there's an app for everything. We want things, machines to do stuff for us. Okay, there's a time and place for that, but not when you're doing negative 32 plus 13. Okay, you can use your calculator to check, but you need to know how to do that in your head. Okay, now what we can do is let's rearrange. Let's make the decision that we want all the p's on the left side. So what I'm going to do is leave that alone. Take this, move it. Okay, that's a negative. You want to add 2p to both sides. So when you move it to this side, put add 2p. All right. Now you want to leave the negative 19 where it is. Okay, that means this number needs to go the other side. Move it. So you're going to add 75 to both sides, so you just add 75. Okay, collect like terms. Very efficient way to write steps. Negative 6 plus 2 is negative 4p. Here we go again. Okay, you're in debt. You give the bank $75, you're out of debt. So the answer of this is going to be positive. Just subtract the 2. Find the difference of the 2. Regroup. Take away 1 there or 10 there to make that 60. That becomes 15. 15 minus 9 is 6. 6 minus 1 is 5. So you got 56. So now we have negative 4p is equal to 56. Now you can divide both sides by negative 4. All right. And that cancels out. That leaves you p. And then you can work this out at the side if you want to. 56 divided by 4. Let me tell you how I do this in my head. If you divide by 4, dividing by 4 means cut in half twice. it's easy to divide by 4 in your head. Half of 56 is 28. Half of 28 is 14. And then a positive divided by a negative is negative 14. Learn to do stuff like that. Divide by 4, cut in half twice. Okay, so what we're going to do next here is do a couple of problems. I'm going to let you do number 9 and number 10. So I am going to pause my recording for a minute. Okay, so let's see how we did. Okay, let's run through this a little bit. And you can write your steps with the ways that you're most comfortable if you want to, like we've been doing. So you got to start with the distributive property. So 3 times 2 is 6z. 3 times 2 is going to be minus 6. This side, 5 times z is 5z. And 5 times 2 is positive 10, so put plus 10. Okay, now if you want to rearrange, you can do it this way. Leave the 6 where it is. Move the 5z like that. Okay, that's a positive, so you're really subtracting 5z, so that becomes minus 5z like that. Write your equal sign, leave the 10 where it is. Move the number without the variable to this side. So you're adding 6 to both sides, you'd have plus 6, right? Problem done. 6 minus 5 is 1z. That's equal to 16, so you get z is equal to 16. That's one way to do it. Some of you also may have done it this way. So step 1, you can also go like this if you want to. You could subtract 5z from both sides. Always like to kind of get students, if you do it this way, to work with your variables first. And if you do it this way, see, that's just z. That's minus 6. This is 0 plus 10, so it's just 10. And then you can add 6 to both sides. So you would get z is equal to 16. So maybe you did it that way. Okay. All right, next problem. What you'll kind of see on this problem is you've got a distributive property. You want to do that, and then also you got some like terms. So you want to put those together. So I'm just going to start the problem like this. I'm going to go ahead and put these like terms together. So negative 8 plus 24 is going to be 16. So those go together. Plus 10y. This side, distributive property. 4 times 2 is 8y. 4 times 8 is negative 32. Bring down to 10. Now notice we have some like terms. Put them together. A lot of times students are really bad about not putting like terms together, and it's a bad habit. Put them together. So this is 16 plus 10y. This is 8y. These are two debts, so that's minus 42. Okay, now if you want to rearrange, you can do that. See, what I'm going to do is I'm going to work with all my y's. They're all going to come together, and then all my numbers are going to go together. So I'm going to do this. I'm going to leave the 10y, move the 8y. Okay, you need to subtract 8y from both sides, so that becomes minus 8y. Okay, I'm going to leave my numbers on the right side. So negative 42 stays. I'm going to move the 16 to this side, so subtract 16. So you're going to have minus 16. Okay, that becomes 2y. This is two debts. That's negative 58. Now you can divide both sides by 2. So what you end up getting is y. 1y is equal to, and then you can cut that in half. That's negative 29. So we get that. So y is equal to negative 29. All right. So you could do it that way. Some of you may have done it this way. The best way to start this problem is to be sure you do distributive property and collect like terms. So you might prefer to do the problem this way. Okay, maybe you want to get rid of, you got variables on both sides. You got to get rid of one of them. So we could subtract 8y from both sides. And if we do that, we would end up having, on this side, we'd have 16 plus 2y. That's 0. 0 minus 42 is negative 42. Then you've got to isolate the y. So you've got subtract 16, subtract 16. Okay, when you do that, you could draw a line if you wanted to. What you'd have is that's 0. So that's 2y. and then that's negative 58. Then you can divide both sides by 2. That'll get y by itself, so you have 1y equals negative 29, like that. Okay, now what we're going to do is some kind of special cases of some things on the next page. So I'll kind of pause this just for a second. Okay, so as we move on to some special cases here, you'll see these sometimes. You can have equations that have one solution, several solutions, no solutions, infinite solutions. There's all kinds of possibilities. You can have equations that don't have a solution, and they can have many solutions. All right, so here's a kind of a way to look at this. If you look at this problem right here, x plus 1 equals x plus 2, you can think of this x as just kind of representing a box. Like I always tell little kids that when I was in first grade, and when you're in first grade, hey, that's when you learn algebra, because you kind of learn how to fill in boxes on addition problems. So this is where you can think of this. Well, the thing is, there's nothing you could put in this box that would work. If you put a 1 there, both sides are different. It doesn't matter what you do. No matter what you put in the box, and you have to put the same number in the box, nothing's going to work. So this is going to be a problem that has no solution. And there's no number that you can plug in for x that works. If you go to this problem, you could reason this out the same way. It's something plus 1 equals something plus 1. Well, on this one, well, if you plugged a 1 in, that certainly works. If you plugged anything in, it would work. It doesn't matter. Okay, if we plugged in a 10, 10 plus 1 and 10 plus 1 are the same. So this one would be, infinite solutions. Everything works. All right. So what you can kind of do on this is, you won't always see this if you're solving equations. Sometimes you'll have this case, sometimes you won't. So if you were going through and solving this problem, and if you didn't see that it had no solution, because you won't always see that, well, one thing you could do is say, well, I've got variables on both sides, so I want to just get all my variables on one side and my numbers on the other side. So one thing that you could do on this is you could say, well, I want to get rid of this x, so I subtract x from both sides. So if I do that, that goes to 0, that goes to 0. So what I'm left with is 0 plus 1 equals 0 plus 2. So I'm left with 1 equals 2. That's a contradiction. If you get a contradiction, that's going to tell you that there is no solution. So a lot of times we put this empty set symbol right there to show that there's no solution. So that's one way you could do this. Another way you could do this is like this. You could rearrange the variables the way we've been doing. So you could say, okay, we got x plus 1 equals x plus 2. I want to rearrange. I want to put all my variables on the left, and I want to put all my numbers on the right. If you did that, you would have x. When you move this, you would have minus x equals, leave the 2. When you move the 1, you'd have minus 1. So you'd have 0 equals 1. Still the same thing. It's a contradiction. Okay. This one you could kind of work out the same way. You have x plus 1 equals x plus 1. So you might see that, well, I don't want variables on both sides, so I could subtract x from both sides. When I do that, I'd have 0 plus 1 equals 0 plus 1, so I'd get 1 equals 1. Okay, that's a true statement. So if it's a true statement, that means that you're going to get infinite solutions to the problem. Okay, everything's going to work. So what we would say on this first problem right here is there's no solution. The second one, we usually say the answer is all real numbers. So every real number satisfies this equation, like that. Okay? All right, so let's go through and work some of these things out. If you can do these in your head, do them in your head. If you need to solve, do it. So let's start this problem out like this. You have x plus 8 equals 8 plus x. It's obviously the same. Both sides are the same. So let's look at doing it this way. We don't want x's on both sides, so let's subtract x from both sides and let's see what happens. That's going to give 0 plus 8. This is going to give 8 plus 0. So you get 8 equals 8. It's a true statement. So what that means is the answer is all real numbers. All right, problem done. Now that one you can do in your head if you want to. Okay, next problem. Notice on this that you have some like terms. So you can put those like terms go together. These like terms go together. Put them together on each side. So if you do that, you'll have 6x plus 6x is 12x. Bring down the minus 8. Bring your equal sign down. 8x plus 4x is 12x. And then you're left with a plus 11. Okay? So if you wanted to rearrange, I want to try to do this in different ways. Let's say that I want to move all of my x's to the left, and I want to move all my constants to the other side. So what I end up having is I'm going to have 12x, that stays. If you move this, you're subtracting from both sides. Okay, the 11 stays. If you move the negative 8 to the other side, you're adding 8 to both sides, so it's plus 8. So you'd end up with 0 equals 19. Okay, well that's a false statement. So since it's false, the answer is no solution. Now a lot of times I see students on these problems, they'll write true or false. It's not a true or false problem. It's not a true or false question. It's does it have a solution or does it not have a solution? Okay, and if it has a solution, what are the solutions? So that's no solution. So that's one way you could do the problem is like that. Okay. The other way you could look at this is after you collect your like terms, you can do it like this if you want to. So you could have 12x minus 11 equals 12x plus 11. So you could say, well, I need to get rid of, I don't want x's on both sides. You could show your step like this if you wanted to. So if you did that, this would be 0 minus 11 is negative 11. 0 plus 11 is 11. Well, still it's a false statement. Okay, the variable disappeared. Okay, next problem. Let's start this one. You got to do distributive property there, distributive property there. Okay, so we want to do distributive there, and we want to do distributive there. So 18 times x is 18x. 18 times negative 2 is negative 36. So you write that as subtract 36. This is 18x minus 6 minus 30, like that. Okay, now you got like terms, so be sure you collect them. Okay, so when we do this, what we'd have is, I'm going to just write that as 18x minus 36. This is 18x minus 36. I already know the answer. If you already know the answer, tell me what it is. These are the same. So if they're the same, the answer has to be all real numbers. You could also show another step by subtracting 18x from both sides. But when you do that, the variables cancel out. You really end up with 0, and then see those are, minus 36 equals 0 minus 36. So you end up with the true statement like that. Again, this is not a true or false problem. It's what are the solutions. So the solutions are all real numbers. So you just write the answer like that. Okay, so that's how that goes. Okay, so we'll go ahead and move on to the next next page and let you do a few problems here. So let's do 14 and 15. I'll pause my recording while you're doing that. Okay, let's see how we did. Okay, start with distributive property on this one. So we're going to do 4x, 4 times 3. So that will be 4x plus 12. This one right here, you have a minus 1 in front of there. So it really just changes the signs. So you're going to do this times this, and then this times this. So that will be minus 4x minus 12 equals 0. Be careful about those signs. Now, when you collect like terms, see, those are like terms. The 12s are like terms. When you put it together, that's 0x. This is 0. So you end up with 0 equals 0. So you do get a true statement. So that means the answer to this problem is going to be all real numbers. Okay. All right, next problem is another distributive property. So you do this times this, this times this. So that's going to give 12w minus 24 on that side. Okay, go to the right side. You're going to do 4 times 3w and 4 times 4. So that's going to be 12w plus 16, like this. Now you got a couple of ways you can do this. If you want to subtract 12w from both sides, or if you know the answer, you can just write the answer. See, the w's cross out. They go to 0. So what you're left with really is 0 minus 24 equals 0 plus 16. So that is negative 24 equals 16. That's a false statement, which tells you the answer is no solution. So that's what you should have got. Okay, you can use the empty set symbol if you want to for no solution. Okay, now we're going to finish up here with equations with fractions, and this is kind of a problem area. And the thing is, if you have an equation with fractions, just get rid of them. You want to eliminate the fractions from an equation to make it simpler, and once you do that, then it's very simple to finish up the problem. Okay, so what you're going to do is you're going to follow these steps generally. You're going to find the common denominator of all the fractions in the equation. Draw a bracket around both sides of the equation, multiply both sides by the common denominator. Okay, and after you do that, you won't have any fractions left. Okay, so the thing is, on a problem like number 16, when you see that you have fractions, you just want to get rid of the fractions. You have 2 fractions, 2/5 and 1/3. And if you look at a common denominator, all a common denominator is it's a least common multiple. It's the first number that both things divide into. So both of these numbers evenly divide into 15. Okay, that's one way to look at it. 5 goes into 15 3 times, 3 divides into 15 5 times. Okay, so that is your least common denominator. Students a lot of times learned how to do this like in elementary or middle school or whatever. You can count by 5, 5, 10, 15, 20, so forth. You can count by 3, 3, 6, 9, 12, 15, so forth. And then they overlap at 15. That's what a least common multiple is. Okay, but a lot of times you can do that in your head. So what we're going to do on this problem is we're going to just start by writing down the equation, which is 2/5 x minus 1/3 x is equal to 2. And I'm going to put a bracket around both sides, or a parenthesis, and I'm going to multiply both sides by that common denominator. That common denominator is 15. So we're just going to multiply both sides by 15. All right, now we do a distributive property. We're going to multiply those two things out. So what we're going to have is you're going to have 15, and I'm going to put that over 1, times 2/5 x, bring that minus sign down. Then I'm going to do 15 over 1, like that, times 1/3 x. And of course, the right side, 15 times 2 is going to be 30. Now, what happens on this problem is when you look at these two multiplication problems, the fractions are going to divide out. There's actually 2 ways you can write this next step if you want to. So you multiply fractions straight across. So if you did that, you'd have 30 over 5 x minus 15 over 3x. And then this side's going to be 30, like that. Now you can divide this out. This is why it works. 30 divided by 5 is 6. 15 divided by 3 is 5. So you would end up with 1x equals 30, or just x equals 30 is your answer. So once you get rid of those fractions, then you're in good shape. Now the other thing you can always do if you want to, I do this a lot, is you can, sometimes we call this cross-canceling. You can divide 15 and 5 by 5. So 5 goes into 5 one time. 5 goes into 15 3 times. So notice you have 3 times 2, so you get 6. Same thing here. 3 divided by 3 is 1. 15 divided by 3 is 5. 5 times 1 is 5. So you can do it that way if you want to. Sometimes that's simpler to do it that way. All right, so your answer is going to be 30. Okay? All right. To help understand this, I am going to check this answer. So I'm going to do 2/5 times the answer minus 1/3 times the answer equals 2. Let's see if it's right. Let's plug in the 30 and go ahead and do a quick check on this. So if we multiply this straight across, you'd have 60 over 5 minus 30 over 3, and we'll see if that's 2. 60 over 5 is 12. 30 over 3 is 10. Is that 2? Yes, it is. So you have 2 equals 2, so it's the right answer. Okay, next problem. First of all, look at your denominators. We have 8, we have 6, we have 4. So what you're doing is you're trying to find the smallest number they all divide into. Now, one way you can do this, depending on your level of skill, is you can work with the biggest fraction. So if you put an 8 there, the problem is 6 doesn't go into 8 evenly, so that can't be the denominator. So what you could do then is you could go on and start again, and you can just say, well, we got 8, we have 6, we have 4. If you count out by the multiples of 8, you have 8, 16, 24, and so forth. Well, notice that 8 goes into 16, 4 goes into 16, but that doesn't work. So you can go on to the next one, 24, and then that's the one that's going to work. You can do it this way if you have to. There's other ways to learn as well. So let's go ahead and work with 24 and see if that's the denominator that's going to work for us. Okay, so if we do this, we have 8 divides into 24 3 times. 6 divides into 24 4 times. 4 divides into 24 6 times. Now the thing is, all of these things right here do not have a common factor left over, so that's got to be the least common denominator. All right, so that's one way to do that. So 24 is going to be what we're going to use. I spend a lot of time in Math 55 showing students how to do common denominators and making sure they have the least. The thing is, if you look at 3, 4, and 6, the only number that divides into those is 1. And since that's the case, that means that you've succeeded in finding the smallest common denominator. All right, so here's what we're going to do to solve the problem. Let's start by writing it down. We have negative 3/8 t plus 2t. And then we have 5/6t plus 1/4. And what I'm going to do is I'm going to draw a bracket around both sides. And we're going to multiply both sides by that common denominator. And I'm going to put that over 24 like that. Okay, the next step is the distributive property. You're going to multiply that by that. You're going to multiply that by that. So we're going to have 24 over 1 multiplied by negative 3/8 t. Then we're going to have 24 times 2t. You can do that one in your head, is plus 48t. Bring down the equal sign. Now we're going to do this times this. So we're going to have 24 over 1 multiplied by 5/6t plus, now do it this way, 24 over 1 times 1/4. So what we need to do is we need to do these fraction arithmetic problems. You got to do that arithmetic problem, and that arithmetic problem. Okay? Now, one of the things that you don't want to forget about is, you know, instead of multiplying fractions straight across, see if you can cross cancel them. It's easier to do it that way most of the time. 8 goes evenly into both of these numbers. So 8 goes into 8 once. 8 goes into 24 3 times. So this is 3 times 3, or 9 over 1. 9 over 1 is just 9. However, you have a positive times a negative, so that's negative 9t. Okay, then bring down the 48t like that. Okay, do the same thing here. 6, both of those numbers divide by 6. 6 goes into 6 once. 6 goes into 24 4 times. So what you have is 4 times 5, or 20 over 1. 20 over 1 is just going to be 20t. Do the same thing here. 4 into 4 once. 4 goes into 24 6 times. So you have 6 over 1. So you just have plus 6. Like that. It's easier to do it that way. Okay, these are like terms. 48 minus 9. 48's going down by 9, so that's going to be 39t. This side, you have 20t plus 6. These are not like terms, so don't combine them. So you want to get variables on one side. I'm just going to do it this way. I'm just going to slide that over there. So I'm going to have 39t minus 20t is equal to 6. So what I'll have is 39 minus 20 is 19t equals 6. All right, when that gets moved like that. And then I can divide both sides by 19. Then I'll have a fraction answer, which is totally cool. So I get t is equal to 6 over 19. All right, so that is the solution to the problem. Problem done. Okay, so you've gotten rid of your fraction. Okay, so I will pause this. I'm going to let you guys work a little bit on number 18 and number 19 on the next page, just the next two. All right, so let's see how we did. I was trying to play some Pink Floyd song there. I hadn't played it in like forever. All right, so let's see what we got on this. We've got common denominator between 4 and 8. You should have come up with 8 there. Now, see, students a lot of times want to use 32 because 4 times 8 is 32. It'll work. It'll give you the same answer. But the smallest denominator is 8 because both of these numbers evenly go into 8. See, the thing is, 4 goes into 8 2 times, 8 goes into 8 1 time. And the only number that goes into 1 and 2 is a 1, so that means that's the smallest. If you used 32, and I suspect some of you did, here's what would happen. You'll still get the same answer, but 4 goes into 32 8 times, 8 goes into 32 4 times. And notice that there's something that still goes into 8 and 4. There's something bigger than 1 that goes into that, so that means that's not the smallest common denominator. So I'm going to use 8. All right, so what I'm going to do is write down the problem. So we have 1/4 p subtract 3/8 p is equal to 5. So both sides need to get multiplied by 8 over 1. And I'm just going to put times 8 on that side like that. Okay, you're going to do a distributive property. So you need to do that. Okay, so when we do that, you're going to have 8 over 1 multiplied by 1/4 p minus, then do 8 over 1 times 3/8 p is equal to 40 when you multiply that together. Okay, now when you multiply out these fractions, say, you're going to do that problem and you're going to do this problem. Okay, you can do it like this, just cross cancel. 4 divided by 4 is 1. 8 divided by 4 is 2. So that whole thing becomes 2 over 1 or just 2p. Same thing here. 8 goes into 8 once. 8 goes into 8 once. You got 1 times 3 or 3 over 1. So you're going to end up with minus 3p is equal to 40. Okay, these are like terms. Put them together. 2 minus 3 is negative 1p. So you end up with negative p is equal to 40. Now you're not done here. You need to divide both sides by negative 1 to complete this. So you end up with p is equal to negative 40 as the answer of the problem. Okay. Now let's do a check on this. Since it's pretty easy on this, we have 1/4 times p minus 3/8 times p is possibly equal to 5. Plug it in. Let's see if this works. I'm going to put a negative 40 in as my answer. Right, put that over 1 and let's see real quick if it works. So this time, just for variety, let's multiply this straight across. That's negative 40 over 4. This is 2 negatives, so that is positive 120 over 8. And we'll see if that's equal to 5. Okay, this is negative 10. If you do 12 divided by 8, what you'll end up with on that is 15. So sure enough, that's right. 5 equals 5, so that proves that's the right answer. Okay. Now see, you can also do this like this. You can go 4 into 4 once, 4 into 40 10 times, 8 into 8 once, 8 into 45 times. Just get the same thing. Okay. Okay, next problem. Let's look at what the common denominator is on this one. And we have 7, 21, and 3. Okay, so one thing you can do if you need a little bit of help on this is take the biggest number and see if everything divides into the biggest number. 7 goes into 21 3 times, 21 into 21 once, 3 into 21 7 times. Now, is this right? Yes, it is, because the only number that goes into 3, 1, and 7 is a 1. Okay, so that's the right denominator. So we need to, on this one, multiply everything by 21. So I'm going to write down the problem. 12 sevenths are minus 121 21r equals r minus 10 thirds. So what I'm going to do is I'm going to multiply both sides by that common denominator, which is 21 over 1. Okay, I'm going to do a distributive property on this now. So what I'm going to have is 21 over 1 times 12 sevenths r minus 21 over 1 times 1 over 21r equals, and we're going to do a distributive property here, so we have 21r minus, and then do a distributive property here, so we're going to have 21 over 1 times 10 thirds. Okay, like this. All right, now we're going to do these fractions. Highlighters are kind of helpful to students a lot of times, and if it's helpful in your homework, do it. So we're going to do this. So just multiply this out. Okay, these divide out. 21 divided by 7 is 3. You can do it like that if you want to. So this is 36 over 1. So that's going to be 36r. Over here, those divide out. So you're just going to be left with minus 1r equals 21r. Same thing, 21 over 3 is 7. So you can do it like that if you want to. So that's 70 over 1, or 70. So we have this. Okay, got like terms on this now. So this is 35r is equal to 1r minus 70. Now I need to move this over here and finish up the problem. Okay. Okay, so let's move this over here. We have 35r is equal to 21r minus 70. And see, you can do it like this if you want to. You could either subtract 21r from both sides, or you can just move it. So you get 35r, subtract 21r, equals negative 70. So 35 minus 21 is 14r. That's equal to negative 70. And then close off by dividing both sides by 14. And we'd end up having the answer. Okay, like this. Now, you can do a long division problem on this, but I want to show you guys something on this too. Because there's so much, I see so many students that don't know how to do stuff like this, who act like they've never learned how to do this, and it's a shame that we're in a society where we just use machines all the time. You could write 70 as 10 times 7, like this, and then look what happens. Okay, these cross out. And then negative 10 over 2 is negative 5. It's just as easy to do it that way than it is to, do long division. So the answer is negative 5. Okay? Do stuff like that. You'll be a better math student if you start learning how to do it like that. Okay, so you should have got negative 5 as your answer on that then. Okay, let's run through one more thing then. Just finish this up. I'm going to do one more problem and then let you finish up with a couple of problems to do. This one, the two denominators were 7 and 6. So what happens on this is you're trying to find a number that 7 goes into and 6 goes into. Now, sometimes students know it and sometimes they don't. If you don't know it, there's a couple other ways to do this. One thing is just count by sevens, which is another thing sometimes students don't know because they don't know their sevens. Well, 21, 28, 35, 42... Count by sixes. 6, 12, 18, 24, 30, 36, 42. Okay, well, 42 is your common denominator, and it's the smallest one. You can do that if you have to, all right? Another thing is sometimes if you're struggling finding a common denominator, if you multiply them together, it'll always give you something that works, but it may not give you the smallest one. So 42 is the way to go. 7 goes into 42 6 times, 6 goes into 42 7 times, and then the results, the only number that divides into 6 and 7 is 1, so that means that's the correct thing. So what I'm going to do is I'm going to start by just writing the problem down as 1/7 times x plus 21 plus 1/6 times x plus 6 is equal to x plus 3, and what we're going to do is draw a big bracket around the left side and multiply it by the common denominator 42. Then I'm going to multiply the right side by 42 as well, so I'm not changing anything. Okay, now I'm going to do a distributive property. Now watch this carefully because, man, this is where students mess up so bad. This plus sign is kind of the separator between what's being multiplied out. So you're going to write down 42 over 1 times this whole thing, 1/7 times x plus 21, plus, and then you're going to write down 42 over 1 times 1/6 times x plus 6, and then this side we can distribute it out. 42 times x is 42x, and then 42 times 3 is going to be 126. How did I do that in my head so fast? Here's what I did. I do 40 is 42, 40 plus 2 times 3. 40 times 3 is 120, 2 times 3 is 6. I use the distributive property all the time when I do mental arithmetic. All right, so here's what we do. Now when we multiply, we got to do this. We don't take the 42 inside the parentheses. You move left to right. So what you're going to do is 42 over 7 is 6. Write the 6 down and write the x plus 21 down. Okay, same thing here. 42 over 6 is 7. So what do? You write down 7 times x plus 6, then write the right side down as 42x plus 126. What students do wrong on this all the time is this. I see this constantly. Like, if you have 42 over 1 times 1/7 times x plus 21, you don't multiply through like that. You don't multiply 42 by everything. You go left to right. Think about this. If you multiply 3 numbers, you don't go like 2 times 3 and 2 times 4. You just go 2 times 3 is 6, 6 times 2 is 20, or 6 times 4 is 24. You go left to right when you do stuff like that. So it's important that you pay attention to that. Okay, move left to right. Very, very important. All right, let's finish it up and see what we get then. All right, now we're ready to do a distributive property. We're going to do that and that, this and this. So we get 6x, and let's see, 21 times 6. Let me show you how I do this in my head. I do 6 times 20 plus 1. That's 120. That's 6. That's 126. Okay, 7 times x is 7x. 7 times 6 is 42. That's equal to 42x plus 126. Okay, got a bunch of like terms. Put them together. Put those two things together. That's going to give 13x. These things go together. Okay, so we can do that the side if we need to. 126 and 42 is going to be 6 and 2 is 8. 6 and 4 is 4 and 2 is 6. So that's 168. And then this side, write it down. So that's 42x plus 126. Okay, I'm going to rearrange. I'm going to leave the 13x where it is. I'm going to move this. So that is minus 42x. I'm going to leave the 126 where it is. And I'm going to move this. So that's minus 168. Okay, so I'm going to do 13 minus 42. That's a negative answer is the first thing you want to see. So just do 42 minus 13. Okay, so that should be 29 minus 29x. This is also a negative answer, so just do 168 minus 126. Okay, so that is negative 42. Then divide both sides by negative 29. And you got the final answer is x, and then see this is a positive. 42 over 29 is a fraction that does not reduce, so that's the answer of the problem. Okay. Okay, so that would be how you do that. The key thing is to me, is the whole key to this problem is getting this on your paper. That step right there. If you get that, you're in good shape. Okay, I'm going to let you guys try the next two problems, and we'll see how that goes to kind of finish up this section. Okay, so to finish this up, and to see how we did here, this problem right here, you're looking at 5 and 7, so 35 is your common denominator. So what I'm going to do on this is I'm just going to start by writing the problem down. So I have 1/5 times r plus 6 is equal to 1/7 times r plus 8. I'm going to draw a bracket around both sides, and I'm going to put a 35 over 1 in front. I'll be doing a distributive property like that. All right, so when I do this, I'm going to just write this. See, I don't distribute the 30 in there. I go left to right. So to start with, I'm going to do 35 over 1 times 1/5. Then after I multiply that, then I'll take it through the r plus 6. Same thing here. I've got 35 over 1 times 1/7 times r plus 8. So do not take the 35 inside the parentheses. Instead, do that, do this, then move left to right. So when we do this, you're going to have, well, 35 over 5 is 7. So that's 7 times r plus 6. 35 over 7 is 5. So that's 5 times r plus 8. Now you're ready to do the distributive property. So that's real key. So you're going to take that, then you're going to take that, distribute that out. So you're going to have 7r plus 42 equals 5r plus 40. Okay? Rearrange, let's do that. Leave the 7r where it is. Move this to the other side, so that's going to be minus 5r equals, leave the 40 where it is. Move the 42 to the other side, like that. So that's going to be minus 42. Okay, so this is going to be 2r equals negative 2. Then you can divide both sides by 2. That's going to leave you with r equals negative 1. So that's the answer you should have came up with. And by the way, this problem is actually very easy to check. I'm just going to do this to remind you that this is not always that hard to do. You have 1/5 times r plus 6 equals 1/7 times r plus 8. Now what I'm going to do is I'm going to replace r with negative 1. Okay, so when I do that, I'm just going to erase this, and I'm going to put in a negative 1 there. This one's actually very easy to check. So put a negative 1, put a negative 1 there. Now you can put those numbers together in parentheses by following order of operations. So this is 1/5 times 5, and we'll see if that's equal to 1/7 times, and then of course this is 7. That crosses out, that crosses out. You got 1 equals 1. It's right. Okay, last problem. What you should have done on this is common denominator, you should have came up with a 72. Okay, so I'm going to write the problem down as it is. Negative 1/8 times x plus 16, and then minus 1/9 times x minus 9, and then equal x minus 6. So what I'm going to do is this whole entire side gets multiplied by 72 over 1, and this whole entire side gets multiplied by 72. Okay? Now, write this step. To me, this is very important. Just write this down as 72 over 1 times negative 1/8 times x plus 16 minus 72 over 1 times 1/9 times x minus 9. Then on this side, you can go ahead and multiply that out now. So that's 72x. And then 72 times 6. You can do this way if you want to. 70 plus 2 times 6. 70 times 6 is 420. 2 times 6 is 12. So that's 432. I find a lot of times doing that's just as easy as doing this. You can also go 72 times 6. Work it out like that if you want to. It's up to you. So that's minus 432. Okay. Now what I want to do is, remember you're doing this left to right. So you're going to do this. 72 over 8 is 9. 72 divided by 9 is 8. So just write this as 9 times x plus 16 minus 8 times x minus 9. And then this side is going to be 72x minus 432. Okay, now do a distributive property. So that's 9x plus 144. Careful here, minus 8x. Real careful here. Negative times negative is positive 72. That's equal to 72x minus 432, like that. Okay, put like terms together. 9 minus 8 is 1x. So that's going to give just x. 144 plus 72. That would be 6, 11, 216. Okay, and then this side is going to be 72x minus 432. Okay, now this time let's rearrange again. Just leave the x, move the 72, so that becomes minus 72x. Leave the negative 432 where it is, and then minus 216 like that. Yeah, I see a mistake. I made a mistake here and I didn't catch it. I think I'm doing this a little fast, so I'm gonna get to where my mistake is. You got to be so careful about little things like this, and I didn't catch this. This should be a minus right there. So look at that. 9 times negative 1 is negative 9. So be careful about that. So let's start over again right here. So this is negative 9x minus 144 minus 8x plus 72 is equal to 72x minus 432. These like terms go together to make negative 17x. These like terms go together to make negative 72. And then this is 72x minus 432. Let's rearrange. So let's bring the 72 to the other side. Leave the negative 432 where it is. Move the 72 where it is. Okay, now those are like terms, so that is negative 99x. And then we got to do negative 432 and 72. I'm feeling lazy, so I'm going to use a calculator. So 72 minus 432 is negative 360. And I use calculators when I start getting into pretty big numbers. I just want to encourage you to smaller numbers try to do without, because it helps your mental arithmetic, and that's very important. So we got x, the two negatives divide out. You have 360 over 99. Now what happens is this fraction does reduce also. So you want to do that. Okay, now you can reduce this fraction in several steps if you want to. I see that everything divides by 9. It may divide by something bigger, but let's just start that way. So 360 divided by 9 is 40. 99 divided by 9 is 11. Okay, so that looks like that would be okay. Oops, another arithmetic mistake. That's why I put the thing on pause for a minute, because I knew I was doing something wrong. Okay, the lesson I want you to learn from that is when you start doing things fast, I'm going a little bit too fast, that's what happens. So be careful. All right, so these go together to give negative 89x. equals negative 360. Now you divide both sides by negative 89, and then you have something that doesn't reduce. So I think your final answer to this problem looks like it should be x equals positive 360 over 89. And that's it. Okay, so that should finish that up. So a couple things. I always thought this was kind of cool. I saw these things on the internet, and I always like to show little things like that. So speed limit thing's kind of stupid, but you know, if you saw that, please go over to the side of the road, work out your algebra so that you're not speeding and get a ticket. All right, this next one, I like this one. This one's funny to me. So life plus love equals happy. Life minus love equals sad. That crosses out. 2 lives equals happy plus sad. Therefore, if you divide both sides by 2, you get life is equal to 1/2 plus happy sad plus half sad. How cool is that? All right. So anyway, hope this kind of helps you on this. A lot of you are going to need to really work on this section to review. Try to do your problems without calculators as much as possible. Also, try to check your work on this, because it'll give you a lot of time to build up your arithmetic skills. A lot of times what I see in Math 55 is students who have poor arithmetic skills and are so reliant on calculators that it causes problems later on in the class and later on in their study of math. Calculators are fine for big numbers. Calculators don't need to be used for small numbers, and because you need to know the rules of arithmetic and know them well. Okay, so work on your homework. This will help you tremendously for things you do later in the class. And I feel like if you get real good at this section, then the rest of the things we do in Chapter 2 won't be that hard to learn. This is the nuts and bolts of Chapter 2, so take it seriously. All right, have a good day.